here, as I see this integral of irrational functions, I see it's actually an improper fraction because this degree in the numerator is higher than the degree in the denominator. So the first thing that I'm going to have to do when that happens is I have to do long division. So remember from algebra how to do long division. I'm going to take x squared minus 9 and divide it into 3x cubed plus 5x squared minus 19x minus 45. And remember, we look at first term and first term, divide x squared into 3x cubed, or another way to think about it is what do I multiply x squared by to get 3x cubed? And that's going to be 3x, and I'm going to line it up over the x term, so 3x right here. And then I multiply. 3x times x squared is 3x cubed, and 3x times negative 9 is negative 27x, and I need to line it up under its like term. Remember, the next thing you do in long division is you subtract. Subtracting will change these signs. This will cancel. I'm going to bring down the 5x squared. Here I have 27x minus 19x. So that's going to be plus 8x, and then I'm going to bring down minus 45. Now I repeat this process, x squared into 5x squared, or what do I multiply x squared by to get 5x squared, and that's a positive 5. 5 times x squared is 5x squared, and 5 times negative 9 is negative 45. Then I subtract. Subtracting changes the signs. These will cancel and leave me 8x, and these will cancel as well. So what I've done here is I've broken this down, and it now could be the integral of 3x plus 5 plus this remainder over this divisor. So this is going to be 8x over x squared minus 9 dx. So now that I have done that with the long division, I know I can integrate this, but I need to take this piece and break it down into its partial fractions. I'm going to do that down at the bottom. So we're going to have 8x over, this will factor into x plus 3 and x minus 3. And so I set it up as partial fractions, a over x plus 3, and then I need another fraction with the denominator x minus 3, and that will be b. Now if I multiply everything by the common denominator to cancel all these fractions, that will leave me 8x equals a times x minus 3 plus b times x plus 3. A little bit squished right there. So now I conveniently choose an x to zero out this b, so I'm going to let x equal negative 3. In doing that, I would put a negative 3 here and have negative 24 equals, putting a negative 3 here, negative 6a. So dividing by the negative 6, it looks like a is 4. Now I do the same thing, but this time I'm going to let x equal 3. So putting it in here, I have 24 equals, zeros that out, and here I have 6b. So it looks like b is also 4. So coming back up to my integral, this is the integral of 3x plus 5 plus putting a over x plus 3, and a was 4, so 4 over x plus 3 plus 4 over, here's my b one, x minus 3 dx. So now I can simply integrate each term, and I've got my solution. So integrating here, I have 3 halves x squared, plus integrating here, I have 5x. Integrating here, I have 4 times the natural log of the absolute value of x plus 3, plus, and over here I have 4 times the natural log of the absolute value of x minus 3, and then plus a constant. So we first did long division, and then we did partial fractions on what was left here to get our solution.